All right, we've got AP Calculus ABA, Unit 6, More Derivatives, Lesson 1, the chain rule. The chain rule is really a fascinating shortcut or principle that we can use to differentiate. And here's the idea. Let's say we have some composition of functions, f composed of g of x. And I want to differentiate the function. So the derivative with respect to x of f of g of x, according to the chain rule, is the derivative of f of g of x times the derivative of g of x. Okay? Another way to say this here is let's say we're taking the derivative of f of g, then we could say that is, well, let's just leave it. Let's just leave it for now. Okay. Let's apply this to a couple of scenarios here. Let me give you one here. F of x equals 2x plus 3 cubed. And I want to differentiate this. Now, I could do this. I could multiply it out. 2x plus 3 times 2x plus 3 times 2x plus 3. And that would take quite a bit of work. I could use the binomial coefficients, 1, 3, 3, 1, and do that. All right. And if I do, that would end up, so I can do it in one step. So 1 times 2x to the third, 2 to the third is 8x to the third, times no 3, so plus 3, times 2x squared, so 2x squared times 3, plus 3 times 2x times 3 squared. This is the binomial coefficient, binomial expansion if you would want to look it up, plus 3 to the third. Okay, and that works out to 8x cubed plus 2 times 2 is 4, 4 times 9 is 36, x squared, plus we get 3 squared is 9, 9 times 3 is 27, 27 times 2 is 54, x plus 27. Okay, so we expand it. There's our f of x, and now we can take the derivative, f prime of x equals 8 times 3 is 24, x squared, 36 times 2 is 72x, and 54. Okay, so we can do it that way. Or we could use this new chain rule thing. Let's try this. Think of this as f of x equals, or f of x equals 2x plus 3 cubed. Think of f of x as x cubed, right? So the derivative with respect to x of x cubed is 3x squared. So take the derivative of the parentheses cubed. That's 3 times the parentheses squared, 2x plus 3. So derivative of x cubed is 3x squared. So the derivative of parentheses 2x plus 3 to the third is 3 times 2x plus 3 to the second. But the chain rule now says I need to multiply by the derivative of the inside. The derivative with respect to x of 2x plus 3 is the number 2. Okay? And let's check this out. Let's see if this works out to be the same thing we got before. 3 times 2 is 6. 2x plus 3, let's expand that, is 4x squared. Plus 2 times 2 is 4 times 3 is 12x plus 9. Okay, equals 6 times 4 is 24x squared. Plus 72x, and 6 times 9 is 54. Okay, and that was a little bit easier than expanding. And you can imagine, what if the power were the 7th power or the 8th power? That would make the first method almost untenable. It would be ridiculously long. Okay, so the chain rule is very powerful, allows us to find derivatives that we wouldn't otherwise find. A couple of more examples here. Let's say we've got the derivative of f of x. We've got f of x equals secant of the square root of 3x. Okay? So let's take a look at some of the derivatives involved. The derivative with respect to x of secant is secant tangent. Secant x, tangent x. Okay, the derivative with respect to x of square root x is the same as the derivative with respect to x to the 1/2, which is 1/2 x to the negative 1/2, which is 1 over 2 square root x. Okay, so the derivative with respect to x of square root x is 1 over 2 square root x. And the derivative of 3x is 3. So let's keep that in mind. Let's work from the outside. Always take the derivative using the chain rule from the outside in. So the derivative of secant is secant tangent. Secant square root 3x, tangent square root 3x, times the derivative of square root. So times the derivative of square root. The derivative of square root is 1 over 2 root. 1 over 2 square root, 3x inside, times the derivative of 3x. And there we have it. Now we can simplify things a little bit. So we have on the numerator secant root 3x tangent root 3x. And we've got a 3 on the numerator. All over. Let's see if I can clean that up. All right. That's not much better. Can't draw a straight line. All right. Over 2 root 3x. Okay? And now you might be tempted to rationalize the denominator by multiplying by root 3x. You could do that. We don't usually do that. Okay? So that is f prime. And I should have said the it's f prime of x equals secant. Okay, I just started taking the derivative. All right, so that's how to use the chain rule in this case. One more example. Let me clear the space here. Okay, let's take the derivative of f of x equals square root x plus x sine x. Okay, in this case, we're going to have to remember the chain rule as well. So the derivative with respect to x of square root x, as we've already seen, is 1 over 2 root x. Okay, 1 over 2 root x. Okay, and the derivative of x is 1, and the derivative of sine x is cosine x, and the derivative of u times v is u prime v plus uv prime. Okay, so these are the rules we're going to use here. So let's start from the outside. The derivative of the square root, so f prime of x equals 1 over 2 root x sine x. What stays inside stays the same. That's the derivative of the square root. Times derivative of what's inside. So we've got the product rule. So the derivative of x is 1 sine x plus x times the derivative of sine x is cosine x. Like that. Okay? And we could simplify this here to sine x plus x cosine x all over 2 root x sine x f prime of x equals. Okay, so that's a little bit of how to use the chain rule. As you can see, it can get a little complicated. The sky's the limit.